Hello students, I hope you had good time solving your difficulties. You had good session of that answers to queries. Today we will see HCF and LCM of three numbers using prime factorization. So we are back to HCF and LCM. Okay, this time three numbers. Okay, and the three numbers are 252, 264 and 390. Well, by which method? Prime factorization method. So let's obtain the prime factors of all three numbers. The first number is 252. This work you can do very easily. 2 1s are, 2 2s are, 1 2 6 are. 2 6 are 12, 2 3s are. Now not divisible by 2. So 3. 3 2s are 6, 3 1s are. 3 7s are and 7 1s are. Next number is 264. 2 1s are, 2 3s are, 2 2s are. 2 6s are 12, 1 remains, 2 6 are. 2 3s are, 3s are. Now 3 11s are and 11 1s are. The last number is 390. 2 1s are, 1 remains, 2 9s are 18, 1 remains, 2 5s are. Now is it divisible by 3? 9 plus 1 10, 10 plus 5 15, 15 is divisible by 3. So 195 is also divisible by 3. 3 6 are 18, 1 remains, 3 5s are. Now it's not divisible by 3. 5. 5 1s are, 1 remains, 5 3s are. And 13 is prime. So got the prime factors. Let us write down. We'll use the arithmetic, the theorem, fundamental theorem of arithmetic, right? Okay. 252 is equal to, बोलिए, 2 square into 3 square into 7 raised to 1. What about the next number? This was first, now second number. 264 is equal to 2 cube into 3 raised to 1 into 11 raised to 1. And 390. The third number, the prime factors are 2 raised to 1, 3 raised to 1 into 5 raised to 1, 13 raised to 1. You may write index 1 or you may not write. Alright? Alright. Now, children, I am going to do both HCF and LCM simultaneously so that comparing both findings you can understand them well. Let's see. Thus, HCF of 252, 264 and 390 is equal to, and here LCM and LCM of 252, 264 and 390 is equal to. Please children, first you underline the powers with same base. Here is power whose base is 2, power whose base is 3, power with base 7. Power with base 2, power with base 3, power with base 11. Power with base 2, power with base 3, power with base 5, power with base 13. In all three, we'll select the powers with same base. Correct? Anything else? Yes. Here, we have power with base 3. Anything else common in all three? No. So now, for HCF, you choose the power with smaller index. Power with base 2, power with base 2, power with base 2. Power with common base is present in all three numbers. Now the index 2, 3 and 1. For HCF, the lowest index. So what you will choose? What you will choose? 2 raised to 1. For HCF, so I am writing 2 raised to 1. For LCM, what you will choose? The power with highest index, and that is 2 cube. So for LCM, 2 cube. And for HCF, 2 raised to 1. We have one more power with common base. Correct? Okay. For HCF, what you will choose? The power with lower index. Index is 2, 1 and 1. So any one you choose here. It is 3 raised to 1. And here for LCM, the power with highest index, and that is 3 square. So write 3 square. Is that clear to you? Well, now HCF is over. HCF is over because whatever was common we took. So 2 into 3 is 6. So HCF of these three numbers is 6. But to find LCM, still we have to go a long way. Chaliye. Now, is there any, in all three numbers, these two powers have common base. The rest, 1, 2, 3, 4 are left. But now you have to check whether powers with same base are common in any of the two numbers, like 7 raised to 1 and 11 raised to 1. Yeah, nothing is common. 11, there is no power with base 11 in the third. यहाँ 7 base, यहाँ 7 base नहीं है. So nothing is common. No power is common with base in any two of these numbers. So what you will do? Write rest everything here. Multiply everything into 7, into 11, into 5, into 13. Now that is going to be a tough job. This is 8 into 9 into 7 into 11 into 5 into 30. Let's take pair. This is 72, this is 77, and this is 65. Well, I'll use a calculator to do that work. Please remember you can't. So that is 72 into 77 into 65. That is 3, nice number. The answer is 360. So that is 3,60,360. So that is the LCM of these three numbers. Is that clear to you? Should I explain this to you again? Yes, I think you will need, because we are going to do only one sum here. Alright, for three numbers. Chaliye. Again. Powers with common base 2, 2, 2 in all three. The highest index is 3. So write that 2 cube. One more power with common base 3 is there in all three numbers. The highest index is 2. So that is 3 square. Correct? Now, there is power with base 11 here, 7 here, and power with base 11. But they are not common in first two numbers. Okay. Now, second and third number, if any powers with same base are available. No. Power with base 11, power with base 5, and power with base 13 are there. So, no common powers with same base in second and third number. Now, we have to check in first and third number. In first number, the power is with base 7 is there. In third number, power with base 5 and 13 are there. So, nothing is common. If it is common, again you have to choose power with base having highest index. Okay? But nothing is common. So, whatever is left, that you have to multiply. And that is 7 into 11 into 5 into 13. And we got the answer 360, which is LCM of these three numbers. Got it, children? Okay, I'm going to give you few numbers, triplets, okay, to find LCM as well as HCF. Okay, fine. Next, we are going to see how to find HCF of three numbers using Euclid's division lemma. Yeah, Euclid's algorithm. I'll pick the same number, children. I'll pick the same number. And we saw their HCF was what? 6. If you remember, the HCF was 6. Now I'm going to find HCF of these three same numbers using Euclid's division lemma. Alright? HCF by Euclid's division lemma. Or you can say using Euclid's division algorithm. Alright? Fine. Let's see. The HCF of these three numbers we already know. It's 6. We found by prime factorisation method. Correct? Now we are going to use Euclid's division lemma. In the examination, if the question is find HCF of these three numbers using Euclid's division lemma, then you will have to employ Euclid's division lemma only. If you find HCF by prime factorisation method, though your answer 6 is correct, you will get no marks for that, because you have to do it by Euclid's division lemma. So how to do? When three numbers are there, okay, three numbers are there, choose any two and find their HCF first by Euclid's division lemma. Choose any two. Can you choose this two? Yes. Can you choose this two? Yes. Can you choose the first and the third? Yes. Any two. But for the sake of convenience, what you do, children, choose the largest two. Choose the largest two. Which is the largest one? 390. And next largest, this. So first we find HCF of 264 and 390. First we'll find HCF of 264 and 390 by Euclid's division lemma. Which is the smaller number? 264. It will become divisor. Larger number? 390. Correct? Do you remember now? 3 digit and 3 digit. 2 ones are table till you get 3. Yeah, 2 ones are 2. So that is 264 ones are 264. 10 minus 4 is 6. This becomes 8. 8 minus 6 is 2. And 3 minus 2 is 1. Correct? Now this becomes divisor and 264 earlier divisor becomes dividend. 1 2s are 2. What is 1? 26 2s are 12, 5 and 2. Yeah, divisible. 2s are 252. Subtract 2, 1 and this is 0. I am not writing. Now division continues because you didn't get the remainder 0. Well, this is 2 digits and 3 digits, correct? 12 ones are 12, but there's no more digits. So 12 ones are 12, only 1 you have to take. But normal division will do this. 12 ones are 12 minus 0, bring down 6. Normal division, alright? And what is that? 12 zeros are. Excuse me, children. What we can do is, yeah, same thing. 12 tens are you can get, no? Alright? Fine. Well, directly you may write 12 tens is 120 minus 6. This is one way. Or what I was doing was also correct because you might get confused. So I thought I'll write directly. Let's see. 12 ones are 12, 0. Bring down 6. If you brought down 6, you have to divide. 12 zeros are 0 and 6. Now the division is over. There are no more digits to be brought down. So this is your final remainder. Remainder becomes divisor and the divisor becomes dividend. 6 2s are 12 and 0. So did you get that? See that? You got remainder 0 and the last divisor is 6. So HCF is 6. Alright, children. Now we have to express that Euclid's division lemma. So I'll write it here. First dividend 390. This you have to write below this, okay? 390 is equal to 264 into 1 plus 126. Now this one 264 is equal to 126 into 2 plus the remainder 12. Now this 126 is equal to 12 into 10 plus the remainder 6. And now final one 12 is equal to 6 into 2 plus 0. So your last divisor is this. Thus HCF of, what is that? Only these two numbers, children. 264 and 390 is 6. But we have to find HCF of all three numbers. Children, the third number left out is 252. And the HCF of this two number we got is 6. Now we have to find HCF of 252 and 6. And whatever HCF you get is the HCF of all three numbers. So I'll write here. Now we find HCF of all three numbers. 252, 264, 390, which is equal to HCF of the left number 252 and HCF of this two number which we got 6. Are you getting me? So let's find out. 252 is larger number and 6 is smaller number. Well, one digit. One digit is extra and this digit is additional. So normal division will continue here. Say 2 ones are table till you get 25. Sorry, 6 ones are table. 6 4s are 24, 1, 12. 6 2s are 12. Well, you got remainder 0. Okay, so what is that? Euclid's algorithm 252 is equal to 6 into 42 plus 0. You got the remainder 0. Thus, actually we found HCF of 252 and 6, which is also the HCF of all three numbers. So directly I'll write HCF of all three numbers 252, 264 and 390 is equal to 6. Got it, children? Okay. Children, what is Euclid's division lemma and Euclid's division algorithm? Is there any difference? Yes, children. What I am writing here, this is Euclid's division lemma. Each step that I am writing, I have written 4 steps. Step number 1, step number 2, step number 3, step number 4. And these steps are written in proper order. Writing steps in order is called algorithm. उसे algorithm कहते हैं. Alright? Okay? I'll give you an example. It may not be very fair, but still, to understand it better, I'm going to give you the example. Suppose in the morning you get up, okay, and you have to get ready for school. So, what steps you will follow? As soon as you get up, you will pick up your brush and brush your teeth, right? Go to washroom, become fresh. Then you may go to your bathroom, correct? You may open the taps, hot water, cold water, whatever, fill the bucket, right? Okay. And same time you will remove all your clothes, even the underwears, right? Okay, fine. And then you will start pouring water on the body. Then apply soap all over your body, scrub your body, again pour water, correct? Wipe your body with your towel, okay? Wear the fresh underwear, use towel to cover your body, go to your room where your clothes are kept. One by one you will wear your clothes. First you will wear your pant, then you will wear your shirt and then pant, put in, correct? And before, if you are using banyan, alright, you will wear banyan before you wear your shirt, right? You will put belt, then you will wear tie, go to the dining table and have your breakfast. You are ready for school, correct? So these steps have to be followed in proper order. You can't do this whole procedure of getting ready for school if you don't follow the steps in proper order. Now just think, you got up, you straight away went to bathroom, okay? You removed your clothes, correct? Then you suddenly realize that you have to go for brushing your teeth. You will brush your teeth. Then again you will go back, you will apply the soap. And then you will go to the dining table to have your breakfast. Just imagine, children. Do you get the proper result here? No. So, certain steps have to be followed in proper order. And following that in proper order is called algorithm. Here, first division step is there, the next division step is there. So the steps are followed in proper order, and that is Euclid's algorithm. I hope you got it. Okay. The last concept now, and that is relationship between HCF and LCM of two numbers. Children, let's see. A relationship between HCF and LCM of two numbers. Alright? We'll have to observe and understand to establish the relationship between any two numbers and their HCF and LCM. I'll take two examples. Observe them properly. Alright? First example, I'm taking 12 and 15. What I am supposed to do? The two numbers we already got. First number is 12 and the other number is 15. Now I am going to find the HCF and LCM. Okay, I'll write the prime factors directly. This is 2 squared into 3 raised to 1. 15. It is 3 raised to 1 into 5 raised to 1. So what is HCF, children? Can you tell me directly? HCF is 3. And what is LCM? Yeah, 3 into whatever is left out. 2 square into 5. So that is equal to 5 4s are 20, 23s are 60. So got it? Alright? Now observe. Okay, I'll take the second example as well and find out. Second, it is 20 and 18. Alright? Let's obtain the prime factors of 20. 2 square into 5. 18. 2 into 3 square. Correct? So HCF, I'm writing directly. 2 raised to 1, that is 2. LCM, it is 2 raised to, I didn't make mistake, no, higher index is picked up. Correct? Okay. Higher index is 2 square. And the remaining ones are 5 into 3 square. Correct? 5 fours are 20. Correct? And 3 square is 9. 29s are 180. Now something that you have to observe and understand. First, I am going to find product of two numbers. जो भी दो numbers है उसके product. Which are the numbers? 12 और दूसरा number 15. And I am going to find its product. What is the product? 180. Here, product of their HCF and LCM. What is the HCF? 3. What is the LCM? 60. Let's find out the product. It's 180. And what do you observe? Product of two numbers is equal to product of their HCF and LCM. Maybe in fluke we got for this. Let's try for the other example as well. Right? Product of two numbers. Product of two numbers. Which are the two numbers? 20 and 18. So what is the product? 18 twos are 36 and 0. Now let's find out product of their HCF and LCM. What is the HCF? 2. And what is the LCM? 180. 18 twos are 36 and 0. Now it cannot be flow. But maybe. So you take more examples, alright, and try and check out. And what you will find, what you will observe, that product of any two numbers is always equal to the product of their HCF and LCM. Understood? Now what you understood is a statement. Alright, it is the relationship. Okay, if I say the first number is A and second number is B. The product is A into B. That is equal to, what is 3? HCF of those two numbers, A and B. And what is 60? LCM of A and B. So this is the relationship between two numbers, two positive integers A and B. A into B is equal to HCF of AB and into LCM of AB. So I am writing that. I hope you understood the relationship. I hope you understood the relationship, children. Let's see. For two positive integers, A and B, A into B is always equal to HCF of AB into LCM of AB. And this is called relationship between two numbers A and B and their HCF and LCM. Got it? Alright. We have established this. You can find LCM. Make LCM subject of the formula. Okay. This will go down. Correct? A into B upon HCF of AB is equal to LCM of AB. i.e. LCM of two numbers A and B is equal to A into B upon HCF of AB. Children, sometimes a question may be asked. Find HCF of two numbers using Euclid's division lemma. So using Euclid's division lemma, you find out HCF. And hence, find LCM using the relationship. So what is LCM? A into B upon HCF. A you know, B you know, and HCF you found. So put those values. Alright. Okay. Clear? Would you like to see one example? Yes. Fine. The same. Question. Find HCF of 12 and 18 using Euclid's division lemma, and hence means what you got, you have to utilize that to find what next you have to find. Okay, and hence find their LCM using relationship. They will give you in full words relationship between these two numbers and their HCF and LCM. Okay, sure. First I have to find their HCF. So I'll use the larger number as dividend and smaller as divisor. 12 ones are 12, 6 is left. Division continues. 12, 6 twos are 12, 0. Alright. So this 18 is equal to 12 into 1 plus 6. 12 is equal to 6 into 2 plus 0. Thus, HCF of 12 and 18 is what, children? 6. Right? Now we know the relationship to find LCM. We know that. बताइए LCM of two numbers. Which two numbers? 12 and 18 is equal to. Okay, we'll write that formula. A into B is equal to LCM of A and B is equal to A into B upon HCF of AB. Now tell me, what is A here? 12. What is B here? 18. Upon what is HCF of A and B in this case? 6. 6 ones are 6 twos are 18 twos are 36, which is nothing but LCM of. Okay. Therefore, LCM of, for A I am writing 12 and for B I am writing 18 because A is 12 and A is 18. Okay, and I can put the arrow here. Correct? So what is LCM of 12 and 18? 36. But we use interrelationship. But before using interrelationship, we found HCF using Euclid's division lemma. Alright. Is there any relationship between three numbers and their HCF and LCM? Yes. Is it similar to what we have for two numbers? No. Children, I'm going to give you relationship, but you derive it at home. Alright. For two numbers, A and B, A into B is equal to HCF of AB multiplied by LCM of AB. This is the relationship, okay? For three numbers, A, B and C, A into B into C is equal to HCF of ABC into LCM of ABC. Using the logic, you might write like this, but this is not true. You check out. आपके पास तीन नंबर ले लो, 10, 12 and 15. तीन नंबर ले लो. What is their product? Find out. What is their HCF? Find out. What is the LCM? Find out. And then check product of the HCF and LCM is equal to the product of these three numbers or not. It won't be. Alright. Then what is the exact relationship? Yeah. So what is LCM in this case? LCM of A and B is equal to A into B upon HCF of AB. Correct? For three numbers, LCM of three numbers A, B and C is equal to A into B into C into, it is HCF of all three numbers A, B and C. Alright? Be careful. Sir, ये तो ऊपर नीचे था, ऊपर है. Yeah, the relationship is that. Upon. बोलिए. Still there is HCF of any two number taken at a time. First AB into next BC. HCF of B and C into one more pair is left, AC. HCF of A and C. This is the relationship between any three numbers and their HCF and LCM. Just check. Here you have to find number of things. You will have to find HCF of all three numbers. You have to find HCF of only first two numbers. HCF of second and third number, HCF of first and third number, and then you check out whether the LCM of A, B and C is equal to the product of their numbers into HCF of all three numbers upon HCF of any two numbers taken at a time. Alright. This is just to remember, no sum would be asked. Well, it's not in your book as well, it's not for study, but sometimes they can ask you in the form of 1 mark question. So this is how you find LCM using LCM of three numbers using interrelationship between these three numbers and their HCF and LCM. I hope you understood and enjoyed the session. Thank you very much.